All right, guys, welcome to section 10.6. And in this section, we're gonna parametrize surfaces. And compute area. Area of surfaces. Number one, parametrize surfaces. Okay, so how do we parametrize a surface? Right. Well, I'm gonna record that. We use parametric equation. RT to describe general curve in R2. For surfaces in R3, we're gonna be used for surfaces in we used, instead of RT, it's going to be RUV. Okay, so a vector function of two parameters. Then actually, I'm going to write RUV here out a little bit. So there's the XUV, YUV, and ZUV. Okay, how do we do this? We can do this by having a region D, because the UV is the point on the region D, and then we use the vector function to trace out the surface. So let me draw out region D here. Okay, so on the region D, you have this. Let's say this is the region D here. Then you have a UV. Okay. Using the vector R, then you can trace out the surface, that the tip of the position vector. Can trace out the surface as we move UV throughout the region D. You use a vector, so there's the vector here, and then you trace it all over. So when you trace it, then of course you're going to trace out a surface here. Bad way to sketch a surface. Okay, let me just give you an example. See how we do the trace here, and then you get an idea of what is going on. Right? Well, here come an example. Use the vector function or UV equal a cosine U, a sine U, and V. Where 0 less than U less than equal 2 pi, 0 less than V less than equal H, to trace out the surface as UV. Right? So we know U go from 0 to 2 pi, V go from 0 to H, and thus we have a region D. Region D. Okay, so now we're going to be using the vector to do the trace here. So I'm just gonna get a particular point in here, so you can get an idea of what is going on here. So let me do a U star and V star here. Let's say this is the U star, and somewhere is V star. Use different color here so you can see. Okay. Using this factor or UV. We use it, of course, we're gonna get something here. So when we trace out, we're just gonna use what we learned before, cylindrical coordinate. U, that is the angle. Right? What we get here, of course, is a cylinder. I'm gonna trace out the U and the V so you can see exactly what is the U here. So for the U star, right, we go somewhere right here for some angle right here, and that angle is the U star. Right? Get this thing here. Okay, so look like it. This one is a little. Why a circle? Is because, well, in a cylindrical coordinate, this is a circle and then the radius is a. This is the R U star V star. Yeah. And if you keep moving the vector, you're gonna trace out more points. So you're gonna trace out the entire surface. Identify the surface. Parameterized by, okay, this RUV equal to V cosine U, V sine U, V, where 0 less than equal to U less than equal to 2 pi, and 0 less than equal V less than equal A, X UV, Y UV, and then last one is Z UV. Yeah? So as you can see, just do X squared plus Y squared. So what you get, because we know cosine squared plus sine squared. X squared plus Y squared is V squared cosine squared U plus V squared sine squared U, and then from there you see that is the V squared cosine squared plus sine squared. So that is V squared. Oh, and then from here you see that it would be, that is the cone here, huh? Because this is exactly Z squared, X squared plus Y squared equals Z squared. Z is V. I already see, okay. However, V is only between 0 and A. But 0 less than equal V less than equal A tell us Z can only be positive. Right? So root of X squared plus Y squared. This is a cone here. This vector function parameterize a cone. The following cone. Okay. So I'm going to draw out the UV here. So you see it's just a 2 pi A, right? This is the region D. And you do RUV, yeah. you're gonna get a surface, and then that surface is gonna be radius up here is also a. Yeah, this cone. Okay, we have a few more interesting example because the next part is, oh, you got to be able to parametrize surfaces. So parametrize the following surfaces. Parametrize the following surfaces. A, the part of the cylinder. X squared plus z squared equal 9. That line above x, y plane and between the plane y equal -4 and y equal 4. If you want to see exactly what the heck is going on, it is best to sketch out. So you have a cylinder. There is a cylinder along the y-axis. Okay, so you have a cylinder, right? But you want it to be above the xy plane. The way to draw this is you're gonna have to draw something like this. And then this one, I'll try to match here. Okay, so oh, the four, yeah, yeah. If you do the other half, then you're gonna get a cylinder. Yep, buddy. So how do we parameterize this sucker? Of course, in order to parameterize the cylinder, we got to use cylindrical coordinate. Then use it carefully. If you look up here, right, it's the cylinder along the y-axis, so we can turn x into it's just a cylinder, right? It's not a solid, right? So the radius is 3 cosine theta. Well, it's the cylinder along the y-axis. It's going to be z is equal to 3 sine theta, and then y is just y. Where Where does the angle theta go from? We know y go from -4 to 4 based on the description. But then the angle, well, you want it to be above the xy plane. So the angle is going to go from, you can actually see the angle here. I'm going to do a little bit more so that you can see the angle. The angles go from here to here. So where does it go from? Yeah, 0 to pi. Okay, and well, this look good, but then you got to use the vector function because you parametrize distance. So it's all right, theta y is equal to 3 cosine theta y 3 sine theta. For 0 less than equal to theta less than equal pi, -4 less than equal y less than equal 4, and this vector function does the parametrization. It parameterizes this surface. Okay, so in part B, I'm gonna have you parameterize this one. The part of the plane z equals x plus 3 that lies inside the cylinder. So plus minus we got 1 and right. Yeah. Okay. First thing is that we have a cylinder. A little bit bigger. The plane is gonna cut this cylinder. It doesn't matter because I'm gonna erase this thing here. So the next step is that we're gonna have a plane that's gonna cut this cylinder. Well, and the intersection is gonna be at x equal 0, z equal 3. Let's have z equal 3 somewhere right here. And at z equals 0, x equal -3. So there's the plane right here. It's gonna cut through the cylinder. Okay, and then if it cut through, then you're gonna have the part that is the intersection. You're gonna have this. See. So we can parameterize it using x, y. So x equal x, y equal y, and then z is equal to a function in terms of x and y, fxy, which is x plus 3. Oh, Man, look at this thing here. It's perfectly okay. Yeah? Where we just have to know where does the x go from and the y go from. Well, you got to project this onto the x y plane, right? If we do the projection, of course, it's going to be inside the cylinder. So it's going to be a disk of radius 1 because the surface is inside the cylinder of radius 1. Region D. Okay. In the region D is, of course, a disk of radius 1. Less than equal 1. Yeah, so y is going to be from negative root of 1 minus x squared, root of 1 minus x squared, and x is between negative 1 and 1. That is how we would parametrize. So the vector function here is just or x, y is equal to x, y, and then z is x plus 3. Okay, so that's the vector function. Well, another way to parametrize the surface is notice that it is inside the cylinder. So we can definitely use the radius and the angle theta to parametrize. X equal to, well, we're going to do all cosine theta. Y is equal to all sine theta. And then z here is, well, if you look up the z is x plus 3. So that is the all cosine theta plus 3. This is because z is x plus 3. Where, well, we have to figure out where does the radius all go from, and then where does the angle theta go from. You parametrize it. The radius all here. Well, this is a circle. If you look at the region D, right, it's lucky that we have the region D here. The radius go from 0 to 1, and then the theta go from 0 to 2 pi from the region D. And then this thing is also from region D. Okay. Here the vector function is the function in terms of all theta, which is all cosine theta, all sine theta, and all cosine theta plus 3.